Hello everyone, and welcome to this video on the Python programming language. So in this video I will test the investment strategy or the investing adage to sell in May and go away. Now this adage states that it's best to have a position in the stock market, aka the S&P 500, from the months of November to April, and it's best to have no position in the S&P 500 from the months of May to October. So this adage is backed by some statistics as well, like the 3 worst days for stock market performance and market history occurring in October, which of course is a month to not have a position in the market. And another example would be the S&P 500 having returned about 2% from 1990 to 2022 from May to October, and has returned about 7% from November to April during that same time period. So with all that being said, I'm on Google's website. It's called colab.research.google.com, and I'm on it because it makes it really easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code. Now if you're going to code along with me, go ahead and click on File, then click on New Notebook, where a new tab will open up for you, and then eventually a new cell will open up for you. Okay, and in this cell I am going to import the dependencies that I need for this program. Okay, so I'm going to import pandas as PD. I'm going to import numpy as NP. I'm going to also import seaborn as SNS, and I'm going to import calendar. And then from date time, I'm going to import date time. And then last but not least, I'm going to import matplotlib.pyplot as PLT. And then I'm going to give my plot a style. So I'm going to just type plt.style.use. And I'm going to use the 538 style. Okay. Next, I'm going to go ahead and click this button here, and this will let me know if I made any mistakes. So let's go ahead and run it, and of course it will run this code here. So let's click on that and run it. So also, before we continue, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell notification. Also, you can get the code or the dataset or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. Also, the material in this video is purely educational and should not be taken as professional investment advice, as I am not a professional advisor. So please invest at your own discretion. All right, so let's go ahead and continue. I'm going to create a new cell by clicking that code button in the top left. And now in this cell, I'm going to get the data. So I need to upload this data set. So I'm going to come over here to the left. I'm going to click this upload button, and I'm going to upload spy.csv, which contains information for the S&P 500. So let's go ahead and click OK for this warning. And we have the file uploaded here. So I'm going to create a variable called df, which will be short for data frame. And I'm going to set it equal to pd.read_csv. And then I'm going to put in the name of the file, which is spy.csv. And then I want to show the data. And that's easy enough just by typing df. So let me exit this here. And now let me run this cell. Okay, and now we can see what that CSV file contained, the information that it contains, which of course are these columns up top: the date, the open price, the high price, the low price, the close price, the adjusted close price, and then the volume. And we can see that this data set has 7,621 rows of data in those 7 columns that I mentioned above before. And the date range is from January 29th, 1993 all the way to May 4th, 2023. Okay, so I'm going to change just a few things about this data set. So I'm going to set the index to be the date, and that's easy enough. First, I'm going to make the date column a date time variable. So I'm going to set this equal to pd dot to underscore date time, and of course we're going to convert that date column. Okay, and then I'm going to set the index. So I'm going to type df dot set underscore index, and I'm going to set the index to be the date, and then I'm going to set in place equal to true so that it does this throughout this data set. All right, so let's run this again, and now I can see that the date column has been removed from up top, and now it is the index or the indices. Alrighty, so let's create a new cell, and now in this cell what I want to do is I want to create a new column to store the daily simple returns, and I'm going to do this using the close price. So I'm just going to type DSR, and DSR will be short for daily simple returns. So DSR is the new column that I'm going to add to the data set, and then I'm going to set it equal to df close. So I'm going to set it equal to that close price dot pct underscore change, and I'm going to input the value 1 for 1 day. All right, then I want to go ahead and show the new column. So I'm just going to type df and then input the new column name, which is DSR, and let's run this. And now we can see the daily simple returns for each day, except of course that very first day. All right, so let's create a new cell, and now in this cell I want to get the log returns. So one key advantage of using log returns in finance is that they are additive. That is, if you have 2 log returns, you can add them together to get the total log return for the period. This, of course, is not true for something like simple returns. All right, so I'm going to go ahead and create a new column called log underscore returns, and I'm going to set this equal to np.log. And then inside of here, I'm going to put 1 plus df DSR. So this should calculate the log returns for us. You can also use np.log df close dot diff. Okay, so these should be equivalent. All right, but I'm going to go with this formula here instead. So let's go ahead and show the log returns. So I'm just going to type df log underscore returns, and I'm going to run this cell. Okay, and now we can see the log returns for each day, except of course this day here. All right, so let's go ahead and create a new cell now that we have the daily simple returns and we have the log returns. The next thing that I'm going to do is I'm going to get and store the month name and the month number. Okay, so first I need to create some lists. So I'm going to create some empty lists to store the values. All right, so the first list I'm going to call month underscore name. I'm going to set it equal to an empty list. And then the second list will be month underscore num, and I'll set it equal to an empty list. So the first list will contain the month name, and the second list will contain the number that's associated with the month. So for example, if the month is January, then month num would be 1, and so on and so forth. February would be 2, and I think you get it from there. All right, so I'm going to next create a loop to gather the daily. I'm going to create a loop to gather these values. Okay, so for I in range 0 to the length of our data set, I'm going to create a variable called df underscore date, and it will be equal to our index. So that's df dot index. So that's the dates, but I want it to be equal to these dates casted as a string. So I'm going to put this in a string, or I'm going to make this a string data type. Okay, so now df date is a string. I just casted it as a string. Next, I'm going to create a variable called df underscore month, and I want to set it equal to df underscore date dot split, and I'm going to split the date on the dash, and then I want what is in position number 1. So for example, all I'm doing is looking at this date here, which I converted to a string, and I am splitting it on this dash. So at position 0 would be 1993, at position 1 would be 01 for this example here, and at position 2 would be 29. So the month is in position 1, and that's what I want to gather, and that's why I put this one here. Okay, so next I'm going to create a variable called df underscore month name, and I'm going to set this equal to calendar dot month underscore name to get the name. So I need to input that month number, which is df month, but I need to cast it as a integer value. So I'm going to put this in an int. All right. So now I think I have everything I need. Let's go ahead and start appending the values to the list. All right. So I'm going to take month underscore name, and I'm going to append the df underscore month underscore name, and then I'm going to take the month underscore num, and I'm going to append the df underscore month, cast it as a integer value. All right. Okay, so I think that this will work. Let's go ahead and run this. All right, it checks out. I'm going to create a new cell, and now in this cell I'm going to store or add the list to the data frame as a new column, or as new columns. Okay, so I'm going to create a column called month underscore full underscore name, and I'm going to set this equal to month underscore name, and I'm going to create another column called month underscore num, and I'm going to set this equal to month underscore num. All right, so let's run this, and it looks good. Let's create a new cell, and now let's show the data. So I'm just going to type df here to take a look at the data set. Let's go ahead and run this, and now we can see our data set contains these new columns: DSR, log returns, month full name, and month num. And just like I wanted, we have the month full name here and the month number here. All right, what's interesting is that it's showing all January, and I am not sure that that's the case, right? So it should not show all January. So that means I messed up somewhere, and I'll tell you exactly where I messed up at, which is right here. So I need to put in index I. So I want df.index at position I, because I want this to keep moving, right? To keep iterating through. So I want this to iterate through every single index here. And so that's what I forgot. And I will have to rerun this again now, and rerun this, and then come down here and run that. And now let's scroll on over, and now we can see the month is changing, which is good. Okay, so that's what we wanted. All right, so January matches with the value 1, February matches with the value 2, and May with 5, April with 4. So everything now looks a lot better. I'm just going to scroll on over here, and we can see the dates are still here for our indices. So we can see January, then all the February months, then the April one, and then May. So this looks really good. All right, so let's create a new cell. And now in this cell, I'm going to group and store the mean log returns in a variable. And I'll just put that in comments here. So group and store the mean log returns in a variable. So I'm going to create a variable called series, and I'm going to set it equal to df dot group by, and I'm going to group by the month num. Okay, and I want the log underscore returns, but I want their mean, so I'm going to put dot mean here, and I'm going to multiply it times 100 to get a percentage. So let's go ahead and run this. Let's create a new cell, and let's use that series variable to plot the mean log returns by month. All right, so I'm just going to type series dot plot, and I need to tell it what kind of plot I want. So I'm going to set kind equal to bar, because I want a bar plot. And then I'm going to give this a title. So let's just put here mean log returns, or maybe return and then percentage by month. And while I'm at it, I'll go ahead and add some X ticks. So I'm going to set the rotation for the X ticks to be 90 degrees, and that way we can see the month numbers rotated 90 degrees. So let's go ahead and run this, and here we go. So this is the mean log return by month. So we can see the month numbers down here, again, 1 being January, 2 being February, so on and so forth, and we can see the log mean returns. So it looks like the month of September, which is indicated by this value 9 here, gives the greatest negative returns, as you can see here, right? Then the next month that give the greatest negative returns would be June, and that's not a good thing, right? We actually don't want any negative returns, right? So we have 1, 2, 3, 4 months that give us negative returns. Now here we have 8 and 9, which is August and September, and I believe those are the months where we do not want a position within the S&P 500 according to this trading strategy to buy in May and go away. I'm sorry, sell in May and go away, and then buy back in November, right? So again, the strategy is to sell in May and go away, and then buy back in November. All right, so there may be something to this investment strategy, but let's go ahead and do a little bit more digging, because this isn't very clear. So I'm going to create a new cell, and in this cell I'm going to create a function to get the seasonality. So I'm going to call this function get underscore seasonality, and it's going to take in a data frame or a df, and then within this function I'm going to create an empty list to store the seasonality. So I'm going to create that list now. It's going to be called seasonality. I'm going to set it equal to an empty list. All right, next I want to loop through the data set, and similar to what I did before, I'm going to create a for loop. So for I in range 0 to the length of the data set, I'm going to create a variable called month and set it equal to df, and then I want the month number, so month underscore num at position I, so let's not forget that. And then I'm going to check if the month is between May, which will be indicated by the number 5, and October, which will be indicated by the number 10. So if month is greater than or equal to 5 and month is less than or equal to 10, then the seasonality will be May to October. So seasonality dot append May underscore October. May underscore October. Okay, and I misspelled seasonality here, so I need to put an A. Okay, else it is between the months of November and April, which are indicated by the number 11 and the number 4. But I don't need to put that here. It's just going to capture everything else. So I'm going to do seasonality dot append November or nov underscore April, APR. Okay, and then once this is done, I'm just going to return the seasonality list. So let's go ahead and run this. Let's create a new cell. And now in this cell, I want to get and store the seasonality to the data set. So I'm going to create another column called seasonality. All right, that looks good. I'm going to set it equal to the function that was just created called get seasonality. I'm going to input our data set, which is df, and this should do it. Let's go ahead and run this. Let's create a new cell. Next, I want to get and show the mean log returns of the seasons. So I'm going to create a variable called seas, set it equal to df dot group by, and I'm going to group by the seasonality, and then I want the log underscore returns dot mean times 100, and let's go ahead and show this variable or show the data. So let's run this. Okay, and now we can see the seasonalities, and indeed it does look like there's something with this investment strategy that may be true. So the returns for May to October seem to be much lower than the returns from November to April. All right, so let's create a new cell and let's just take a look at this more visually. So here I'm going to visually show the mean returns of the seasons. So I'm just going to plot C's, and again I'm going to tell it what kind of plot I want, which will be a bar plot, and I will give this a title. And I say again, but it's not really again, it's the first time that we're doing this for C's, but I meant again using plot. So now we're going to give this a title. So I'm going to call this Seasonality, mean monthly log return percentage from 1993 all the way to May 2023. Right, that is the data set, I believe. Yes, all the way to May 2023. Okay, so that looks good. I'm going to give this plot a label on the x-axis. So I'm going to type plt.x label, and I'm going to put seasons, and then I'm going to give the y-axis a label. So I'm going to type plt.y label, and then put mean log returns. Okay, so let's go ahead and run this. All right, let's see where I may have messed up at. It looks like it is here for C's. So I put kin here instead of kind. So just need to put a D here. Let's go ahead and run this again. And now we have our visual chart. So again, we can see that we get greater returns, or have gotten greater returns during the November to April seasons as opposed to the May to October seasons, which kind of shows that selling in May and going away may be a possible good strategy. So it's kind of interesting. All right, so thank you all for watching the video, and a special thanks to the Patreon supporters on patreon.com. Again, if you would like to become a supporter of this channel, then I will leave a link for that in the description below. It will be patreon.com/computerscience, which is where you can get the code and the data set, like I said, or just support the channel, and I'll put that in the description below. Thanks for watching, and I hope you all have a wonderful day, and I will see you all in the next video.